Hello guys, my name is Prince and this is Math Center. Subscribe to my YouTube channel for more videos. Post your comments and questions on my social media handles and I'll respond to it. We are on the topic vectors. In the previous video, we learned how to find the coordinates of the vertex of a parallelogram. We solved a question on it. In this video, we are going to solve another question on finding the coordinates of the vertex of a parallelogram. So let's take the question for this video. The coordinates of the vertices of a parallelogram QRST are Q16, R22, S54, and TXY. Find vector QR, vector TS, and determine the values of X and Y. Calculate the magnitude of vector QT. Leave your answer in said form. When you are being given a question like this, it will be very good for you to draw a diagram for the question. And that is exactly what you are going to do. The coordinates of the vectors given us are Q16, R22, X54, and TXY. So we will draw a parallelogram and we name the vertices as we saw in the previous video. The vertices given to us were QRST. So in naming the parallelogram, make sure that the vertices run smoothly around the diagram. Now this is what I mean. You see here I started from Q. The next one is RST. I could have gone this way, QRST. It doesn't matter where you start from, but make sure that where you start from, the naming of the vertices follows the order that was given to you in the question. So here the order given to us was QRST. So make sure that it goes round, the QRST will go round the diagram. So don't change the order. So it shouldn't be QSRT. You see, when you do that, you have changed the order that the question gave you. That is wrong. In naming it, make sure that it follows the same order as you were given to you in the question. So here, QRST. It doesn't matter where you start from. You have to make sure that you maintain the order. So you can start from here, QRST or QRST. Make sure that you maintain the order. Where you start from doesn't matter. Okay, so we have drawn the diagram for this question. Let's go on and find for the first part. The question says that we should find vector QR and vector TS. From there, we can determine the values of X and Y. So let's begin with vector QR. We know that vector QR is the same as position vector R minus position vector Q. The coordinates of position vector R are the components of position vector R are the coordinates of point R, which is 2, 2. So the components are 2, 2. Minus the components of position vector Q are the coordinates of point Q. The coordinates of point Q are 1 and 6. So the components of position vector Q will be 1 and 6. We have 2 minus 1, which is 1. 2 minus 6, which is negative 4. So we have found vector QR. Let's find vector TS. Vector TS will give us position vector S minus position vector T. We have explained this in the previous video. So vector TS is equal to position vector S minus position vector T. The second one minus the first one. The component of X will be the coordinates of point X, which are 5, 4, minus the component of T will be the coordinates of point T, which are X, Y. And this we know from algebra that 5 minus X will give us 5 minus X. 4 minus Y will give us 4 minus Y. Now look at something. From the diagram, you can see that QR, vector QR is equal to vector TS. We saw this in the previous video that for a parallelogram, considering this particular parallelogram, vector QR will be the same as vector ts. So the opposite vectors are the same. So this vector qr here will be equal to this vector qts. In the same way, vector qt will be the same as vector rs. Okay, but this time we are considering qr and ts. We have been able to find qr and we have been able to find ts. If they are equal, we can equate these two vectors and find the value of x and y as we did in the previous video. So we are going to equate. We know that qr is equal to ts. So qr is 1 minus 4, ts is 5 minus x, 4 minus y. So you say that 5 minus x, 4 minus y is the same as 1 minus 4. From equal vectors, we know that the s component here, which is 5 minus x, is equal to the s component here, which is 1. So 5 minus x is equal to 1. From linear equations, we make x the subject and we find x to be 4. In the same way, 4 minus y is equal to minus 4. So 4 minus y is equal to minus 4. We make y the subject and we find y to be 8. So we have been able to find x and y. X and y are the coordinates of point T. So we say that the coordinates of point T is 4, 8. 4, 8. The question goes on to say that we should calculate the magnitude of vector qt. To calculate the magnitude of vector qt, we first have to find vector qt. Vector qt is equal to position vector t minus position vector q, the second one minus the first one. Coordinates of t, so components of position vector t are 4, 8. We just found that in the previous slide. And components of position vector q are 1, 6. So it means that qt, which is t minus q, is equal to 4, 8 minus 1, 6. 4 minus 1 will give us 3. 8 minus 6 will give us 2. So we now have the components of vector qt. So we can find the magnitude of vector qt. In the video on finding the magnitude of a vector, we said that if you want to find the magnitude of the vector, it's the same as, is equal to square root of the s component, in this case 3 squared, plus the y component, which is 2 squared. So this is going to give us square root of 9 plus 4, which will give us square root of 13. The question said we should leave our answer in set 4. In the video on sets, we said that square root of 13 is a set. So you are going to leave your answer like this. You don't know the units here, so square root of 13 units. This is our answer in set 4. I hope you enjoyed this video. If you did, please don't forget to like and subscribe. You can post your comments in the comment sections. Share this video with others so that they can also enjoy it. In the next video, we are going to learn about the negative or inverse vector. Bye-bye.